is pretty cool, because I think most of the time we think of DAOs as being like a bunch of people who come together and do stuff or have some sort of common interest. But it's interesting to think of how they can be doing useful things for society and organizing large data sets and making something that's bigger than the sum of the parts. So today, just by how do I get into the Zoom here? Okay, there's the Zoom. I guess I shouldn't move around too much. Okay, or I can move this.
No, don't worry.
Okay. Okay, so my name is Michael. I'm from New York, but I'm very happy to be here in London. And I just recently finished my PhD. I was at Stanford studying natural language processing. And after that, I became interested in sort of data and how to use blockchain to create large data sets, or to create like a new style of database. So a database that wasn't like Postgres, that wasn't like MongoDB, but we like rethought a lot of the primitives around databases. And so like, if you just want a high level thing, you can call it like Firebase for Web3. So if you look at a lot of the things, like why do we need a Web3 native database? So on the storage side, you have like S3, and there's like the Web 2 version, and the Web 3 version of that is like IPFS or Arweave. And on the hosting side, there's like a Vercel and for Web 2. And if you want a Web 3, I think you do like a Fleek. And for each of these like very primitive parts of the computational stack, there wasn't any sort of big database that was really meant for Web 3 style applications. And of course, like the database is one of the most fundamental parts of any sort of web application. So if you're building an Instagram, if you're building a Twitter, if you're building a note-taking app, like the heart, like the way it looks is there's a database at the center part of it, but then also you build the UI on top of it. So what we wanted to do was use what people were very familiar with in the ideas around like Postgres or GraphQL, and basically build like a Web3 version of that, so that people could reuse sort of their existing CRUD web applications, which stands for create, read, update, delete, which is this very well-known way of building web applications, and build like a Web3 version of that. And so this talk is going to be about some of the design decisions we made and how it works, and also a lot of the Web3 crypto native ideas that are behind what a database looks like with incentives and with staking and with wallets. So why do we want like a Web3 database is the first one is like the concept we have now around databases only being you put your data into a Postgres database in Facebook servers, and then that's the last you hear of it. Besides, they might get deleted or it might get, stay there forever. But in a Web3 database, we thought people should have, once they put that in their database and that data is very successful, you should be rewarded if your data is successful in that database. So we try and build in incentives into DBDAO so that the people that contribute data are partial owners of this database, and that they earn either tokens, whether it be USDC, or a token native to the whatever the web application is. The other thing is data should sort of live forever in cases where you want it to live forever. So if a major web application goes out of business, say Facebook goes out of business, you still want to be able to keep your posts down the road. Those shouldn't disappear. Or if it's like scientific data where you're conducting a scientific experiment, you want that data, you want to be able to do a Merkle tree root hash of that data set and keep that permanent so that it can be referenced into the indefinite future. It shouldn't just live on top of one on one server, and if that server crashes, you're sort of hosed. So we built it on top of IPFS. The other thing that you would want in a Web3 is like one of the really cool things about Ethereum is it gives you like a universal namespace. So what that means is you can reference things sort of using a hash or a UUID. And right now, a lot of databases are siloed. But in the future, you should be able to link between different data sets. So if I have a data set here and another lab has a data set here, and we have some sort of relationship between these two pieces of data, you should be able to use the universal naming structure of IPFS or smart contracts or something in order to be able to link between multiple data sets. Data ownership, you should own your data. That's very much related to the incentives. You should be able to encrypt data actually if you want. So you should be able to encrypt certain columns. And if you're the person who owns that key, you should be able to grant other people access to certain rows or columns within your database. It needs to be tied to, a Web3 database should be tied to someone's identity to provide data provenance. So if a scientific lab, if a lab machine, or say a temperature sensor, is later found out to be broken and it wasn't calibrated right, the identity of that device should be known and you should be able to revoke some of that data. And then it has to be interoperable just sort of in general with Web3 primitives like the wallet and other Web3 protocols. So I just want to give like a quick overview of what DBDAO is, so if you don't pay attention anywhere else. So basically DBDAO is a DAO for a database. And the DAO that is in charge of this database takes the place of the database admin, who typically decides whether or not data goes into the database or gets rejected. So that's like Mark Zuckerberg's role at Facebook. He is the admin of that database. He decides whether data is part of the terms of service or not part of the terms of service, and decides which types of content should or shouldn't go out. But in DBDAO, that role of the database admin, or the person who controls the types of content that are in the database, is taken by a multi-sig like a DAO. And then the other sort of very cool thing about DBDAO is that every row within the database is an NFT. So this grants individual people who own a row within a database to be partial owners of the database. So the database has many owners: the person who organizes it, who is the curator of the data set, as well as every contributor who contributes to the data set are all partial owners. So that's cool because then when the database monetizes, so the database can monetize through many different ways. People can post ads next to the data, and then that data will then, those views will generate ad revenue, which will then pay the people who curated the data set in the DAO, but also the individual row holders of the database. And sort of if you take another step back, is like, where is the economic value here actually created? And one individual row that someone has doesn't have a ton of value. So if I have one piece of data around a health record, it's not super interesting. But when we have 1,000 or 1,000,000 pieces of data, there's something that's there. The sum of the data is greater than each of its parts. And so there's some value that's created in collating a large set of data. And what we do is we take that value that's created by when people use the blockchain to coordinate and to reduce costs. That creates value, and then we split that up between the people that contributed to the data set. So that's sort of where the value is coming from here. So here's how it works: is every row in the database is a ERC 1155. So this is basically the NFT standard that is very common, and we chose this so that it's very interoperable. So and instead of, when we talk about NFTs here, like oftentimes people think of NFTs as being like a picture of an image or like a Bored Ape or something like that. And what's behind that is like intellectual property. So what makes a Bored Ape interesting is the intellectual property that's backing that Bored Ape. And in this concept of a database, the intellectual property that's backing the row is the JSON object of what the person has contributed to the data set. So in this example, if someone has an X-ray, they push their medical record of their X-ray data into an NFT. They submit it to this popular database. That popular database generates money. The money then goes to the person who submitted the row. And what's cool is because this row is a token, it can be bought or sold by individual people. So you can take your row that you've created and go post it on OpenSea, and it has some predictable cash flow. That's like, say you have a post on Instagram that is very popular, it's generating ad sales. That post is maybe generating $10 a month. Someone offers you $100. You go to OpenSea, you sell your row, and then that person is then entitled to the residual income that it generates in the future. Okay, so this is interesting, but if you can put your row into a database and start generating money, what's going to happen is you're going to have bad actors that are going to want to start putting rows into your data set they're just putting spam in there, because they know if your data set has 100 rows in it and each person gets 1% of the total income of the database, if they put in 1,000,000 rows, they're going to get 99.9% of the data set of the money that's generated from that data set. So we don't want that. That creates bad quality data, and one of the points of DBDAO is to create high quality data sets. So how do we solve this problem? So we incentivize people to put data in with the carrot of you are entitled to residual income from the database. But we also have to disincentivize bad actors. So the way we do that is we make people stake on their data. And so what that means is when you contribute a row to a database, you have to stake maybe $1 or 50 cents. This is a number that's set by the database, the DAO itself, of what they want that staking to be. So if it's, it could be 10 cents, it could be $1, it could be $5, whatever. And if the row is accepted into the database by the DAO, that person gets their deposit back. But if they're submitting spam or it's rejected, then that row gets slashed and that $5 or $1 gets put back into the pool and basically distributed amongst the row holders. And what's cool about this is if someone wants to like run their mouth on Twitter or something and just contribute a lot of spam, what they're ended up doing at the end of the day is they're just sort of funding this data set, and the people are happy to be a punching bag for a certain cost. So that's kind of like a fun thing to incentivize and disincentivize bad content. So how does the database admin work here? And we use a gnosis safe to do that. So the person that's in charge of the database isn't actually a person, it's a DAO. And the DAO in this sense is a multi-sig run by gnosis safe. And what's interesting is, this DAO can be many things. It can be one individual person. If it's just one, there's a lot of people who are using it who are just one person who's deciding which rows should or shouldn't be there. It could also be a team of people. So there's some things where you want 2 of 3 signatures in order to accept data into the database or to reject data from the database. It could be like a jury. So in some ways, a jury system that we have in the US is, you need a certain number of people who are randomly selected to decide whether or not data should or shouldn't be. So you could have a large pool of 1 million people who have opted in to adjudicate claims on whether or not something falls within the terms of service. It could be a traditional DAO that's backed by something like Boardroom. It could be you could pay people to be your administrators of your database, which is like crowdsourcing it on Mechanical Turk. Or I think the one that I'm very excited about is also using ChatGPT or AI to give it 10 examples of things that this is spam and this is not spam. If anything is closely like this, automatically reject it or flag it. And then if the human gives it another signature, then reject it. Or if it's, so using AI to adjudicate claims around what types of data should or shouldn't be allowed into the data set. So last is one of the last things is data privacy. So you want to be able to protect your data. So we use lit protocol to be able to encrypt certain columns. So what's cool about lit is the way it works is if someone is the holder of an NFT, they get the private key to decrypt a row within a JSON object that is in the database. So this is good because you can make some of your database in plain text, but then you can also put parts of it into that are encrypted and won't be seen unless a person pays. So if a person pays a little bit of money, then they get the keys to decrypt the data set and view the encrypted part. Let me give you a short demo here of how it works. So here's the interface of how you make the database. So in this database, we're going to be creating a database for microclimates. So we created this sort of schema creator. So we create a microclimates database so people can enter in the climates around the world. And you give it a short description. And then you add various fields here. So here we're going to create a location and set the type of object that it be. So you can get a string, a number, a image, or whatever. And then you see here it's minted to a specific wallet address. And so then this creates like a little form here. It's very similar to Google Forms. So you can add a row to the database. So we'll say Berlin. And there's Berlin. And then what's cool is, so the database is actually an NFT as well. And you can see here, we'll view the database as an NFT on OpenSea. And you can see where it's written on the smart contract on Ethereum. And you can see the IPFS object that is backing that piece of data right here. And then we'll look at the individual row as well. And you can see that row is minted to a specific person and also available to be bought and sold on OpenSea. You can see the Etherscan, and you can see the sort of the IPFS object that is backing this. So what's cool is from the developer's point of view, this all looks like a this all looks like you can access the data using a URI that is very similar to that uses Prisma and GraphQL to query this data set very easily. So you don't have to change really anything to do with with how your existing web application works. You can sort of have a drop-in replacement for a database that you're already using, but now give reward people with NFTs and using a DAO to decentralize your governance of your web application without changing sort of any of the business logic or backend. And now I want to talk a little bit about the reward structure of how it works. And the way it works here is the network takes 10% of the revenue that comes in through the sales of the data. The database admin, the DAO itself, takes 30%. And these numbers are all flexible and can be set. The scouts, the people that actually contribute the data to the data set, have to be rewarded as well. So they get 60% of the overall pool. And then we're also playing around with this idea that the person who views the data in some circumstances should be rewarded. So they're giving their time, and they should get a percentage of the revenue as well. Now I'll just take like 2 seconds to pitch other things. I started DSi NYC. If any of you are in New York, we hold meetups once a month. You guys are all welcome and invited to come. You can find out more information at this link here. I'll let some people take some pictures. You guys just, there's a sign up and you can join our Telegram chat as well. And then secondly, we're also hosting a decentralized science fair, which is going to be very exciting. We are actively looking for people to participate. If you're interested in sponsoring a prize, we're very open to that as well. And the idea behind this is we already have Avalanche helping with it and the Stanford Blockchain Club. And the idea here is to use the blockchain as a science fair. So you can have a scientific question that you're interested in pursuing, but you can also pursue something in the way science is done using the blockchain. So you can innovate in the science realm, but you can also innovate in the process of science. And both of those types of contributions will be accepted into the science fair. It ends on March 22nd. So if you're interested, reach out to me. And here's the bottom thing is my Telegram. And there's some other information about DSi NYC and the Decentralized Science Fair. And I will now take some questions from people if anyone has anything to say.
Yeah, thanks for the great talk. So I think one of the crucial points is how to assess the quality of the data set and of the single entry. So if we take this example of entering the microclimates, I could enter any temperature and moisture degree and whatever. How would you try to find out if this is good data or bad data?
Yeah, so that's the job of the DAO. So the DAO needs to have domain expertise within. So DB-DAO is the software that sort of runs around it. But we don't have expertise in the microclimate, but we are working together with someone who does have really expertise and who knows the people that will be contributing or has the ability to validate individual data sets. So the role of the DAO in this case is those people actually need to know what they're doing. And they need to understand the science or the technology or the social setting or the people that are contributing. And each DAO will set different standards by which they accept or reject data. But from the outside perspective, it only looks like an accept or reject. And how that internal process goes is sort of up to them.
But wouldn't it be interesting to have questions where we don't have a definite answer and then we don't exactly know if this is good or bad data? For example, with the X-ray example, people can upload X-ray images and they might not have cancer, but a different condition that also leads to this kind of image. So this is very hard to discern if this is really good data or bad data, right?
Well, each DAO, each data set has a specific purpose. It has a charter of like, oh, we are going to create a data set for people that are sick or people that are healthy or people that are sick and healthy. And depending on what the charter of that database is how they will go about. If it's a very unorganized and unstructured data set, that is okay too. They're allowed to do that. But it just sort of depends on what the underlying purpose of the data set is.
Fire check.
It's not the fire alarm?
No, that's not the fire alarm.
It's still the fire alarm, yeah.
Maybe someone is calling you on your computer?
On me.
Actually, that should.
Someone's calling you, Mike. I don't know.
Did you have a question?
Yeah, I just had a question regarding how you identify spam bases. You said that you would leverage some AI into it, but theoretically, for example, we're going to take the imaging data, for example, and we would use guns to generate a lot of like images where the computer is no longer able to differentiate whether it's an original image or a fake image. Like, do you take those things into consideration, or in the medical domain without synthetic data generate?
Yeah, so I mean, that's the AI can be used in some circumstances to detect spam. It's not a solve. It's not data is very broad. So I think AI like ChatGPT would be really good in identifying really bad quality spam. So things that are obviously spam that you don't even want a human to look at. For the more subtle use cases, it'll require a human to look at or to know the provenance of the data. So to have a trusted relationship with an institution that you know their machinery or you know the people within it. But I think it's going to vary a lot dependent on the specific use case of what the data set is.
Could I have the opportunity to deploy that then in a private kind of setting that I would still like? I know that's going to move the decentralization back to the centralization, but leverage that database basically by being the governor, for example, saying only hospitals would have the allowance to actually contribute to my database.
Yeah, you can do that as well. Yeah, and you can also encrypt things to make them, you can allow, there's different parameters that we can tweak. I just kind of went with the simple use case here. Yeah. Yeah, we'll go, you're then, yeah.
Okay, so I'm still kind of new to Web3, so this might be a dumb question, but so you mentioned like each row of the database is an NFT, right? So
Yeah.
if I'm understanding blockchain correctly, is one of the advantages is like the immutability, right? So once it's on chain, it's always on there. So what if like say we use like a temperature sensor, but later we found out like, oh, that sensor is like different, it hasn't been calibrated correctly. So how do we like add it or delete those?
You can always remove something from your database.
Okay.
Or the person can have the ability to burn an NFT as well.
Burn,
And
okay.
remove it as well. So the database can remove it or the row holder can remove it.
And second question is about the efficiency and scalability. So how does this like decentralized database compare to traditional like centralized database?
Yeah, I mean, it's a little bit more expensive, but we got the cost per row for a write to be like a tenth of a penny or something. It's not a lot. And if you pipeline it, you can even get it down because a lot of the transaction cost is this overhead that Ethereum has. It's like half of an Ethereum thing is just to get started on it. And then the rest is the transaction. If we can pipeline that second half, we can save quite a bit. And then reads are basically free. Yeah.
Thank you.
Actually, just follow on that last bit before my actual question, but like it's like if you wanted to like write a lot of data, I guess you could like write it in like chunks or something.
Yeah.
Like to sort of save.
Yeah, so that's exactly how we can reduce costs. Like a lot of like when you're looking at a transaction, if it's this big, it takes this much to get started, and then this amount is the transaction. But we can pile in 50 transactions here and make the cost per transaction really low.
But my actual question then was, does your like protocol system allow for like you could have like a database where data points, like some are like this bad and good, like there could be like a range of like the quality of the data, right? And maybe you will want something like reward the user like quantitatively according to
Yeah.
what's like a particularly good.
Yeah. So how the rewards are done is one, I didn't talk about this here, but there's a couple different ways. You can either, if a database makes $100 and there's 100 rows, each person gets $1. You can also do it where it's like Spotify does it, where like you look at the number of minutes that have been listened to, and then you split it up based on quality. You can also do it based on like something called a Sharpe value. So some data contributes more overall information to an overall data set than other pieces of data. If two people have the same piece of data, that second piece of data contributes no new information. So you can calculate some different values to calculate the new amounts of information. And I think that's an area that's very open to discussion, is how the reward's done. The easiest thing is to just take the money and split it between everyone, but then there are more complicated things as well. Yeah.
I have a question. I am not very versed in Web3. I'm a biologist, so explain me like I'm 5. What kind of data can you handle at the moment? Is it just images already or Excel file? How would a scientist upload their data?
Yeah, so great question. It can handle basically videos, images, text, that all gets converted into a JSON object. And we have an API to do it. If you want to, on our website, we have a light paper that has code snippets and examples of things that you can upload it. But we also have a UI interface that I showed here where you just upload individual things so that you can just upload an image or an individual thing. And I think that's cool because like if like 10 different labs are working on it, something together, maybe a sociology study or a biology study, you can just have the people fill out the information. Like we're working with HairDAO to have individuals contribute individual pieces of data, and then that all gets collated to a decentralized database that they can then query. But yeah, so there's basically an API when that's on our light paper, or you can use like a web, we have a web interface as well.
So to suggest we do a final question, and then if you're available,
Okay,
everyone wants to stay, but yeah, there are other things starting in the other room, so I just want to flag them here.
If you compare it with ceramic, I don't know if you're ready.
Yeah. So I mean, this is a very drop-in replacement for a Postgres database, and it works pretty well. It has a very simple use case, and every row in it is like an NFT. It has a decentralized governance model of how data is accepted or rejected from the data set. And we put a lot of emphasis on incentives, whether they be through USDC or through an existing token.